everyone. I'm Isaku Yamahata and working for Intel. In this session, I'd like to discuss about the current existing KVM guest memory management and what is missing or what is technical gap to be filled and its future direction. And I'd like to make this session as a starting point for discussion or future to make progress. In early phase of KVM development, the design decision was made to reuse the existing Linux infrastructure as much as possible. The main reason is KVM is a part of Linux, so it should blend in Linux source code, and it should not reinvent a wheel, and invent wheel. And the major component of KVM is guest memory management. And naturally, it was built around existing Linux memory management. Linux memory management is basically conversion from virtual address space to host physical address space. So KVM guest memory management is built around on sort of a page fault interface and Linux page, struct page, and so on, so on. That's the current situation. But the design decision was made long ago, and the situation has changed a lot. And we are seeing lots of emerging new requirement for memory. And typically, usable memory has increased, so we'd like to utilize large page for performance or for low overhead memory management, because page granularity to assign to guest memory is much larger than guest. It's not 4 KB. 4 KB might be too small. Well, on the other hand, to increase memory density, we'd like to actively swap out guest memory, or to buy firm or remote memory, or by compression, or by NVDM technology, or so on. And there are several academic research on academic paper on it. And also, we are seeing memory encryption to protect memory guest data from even from host kernel or hypervisor, or even from firmware. And also for security reasons, memory isolation is also highly desirable to isolate host kernel, user space, hypervisor, even only hypervisor as a KVM module, or guest memory. This afternoon, there are also another sessions for memory isolation. And also for fast reboot, yesterday there was a session on it. And his POC is to utilize reserved memory to store guest memory, but just reserving memory is not flexible. So we'd like to only reserve only when really reboot wants to done. So when we'd like to do fast reboot, we'd like to reserve the memory and then move to guest memory from existing one to reserved memory. So that management will be easy. And so it's so because things has changed a lot, so it's time to revise it and to make KVM guest memory management easy for new technologies. So basically, what we should do for new class of memory. And the basic blocker is the early design decision to tie KVM guest memory management to Linux memory management. And everything is built around Linux memory management. And so basic idea is to decouple KVM guest memory management from Linux memory management. And yeah, that's the basic idea. And fortunately, yeah, so yeah, we don't want to require guest mapping, QM mapping. Currently, KVM guest memory requires virtual memory in QM, but we don't want that. And also, yeah, we don't want to depend on kernel struct page. Fortunately, yeah, right now already KVM kernel module doesn't depend on struct page already. And also, we don't want to depend on kernel direct mapping for security reasons. And also, as a result, yeah, we don't want to use case of D for overcommit. So, typically, yeah, new memory technology is implemented as a device driver, and then various operations is done through those device driver. So we'd like to modify current KVM guest memory management to use those device drivers. And also for overcommit, yeah, we'd like to scan access bit or dirty bit in an EPT page table, so that scanner or swapper can identify which page should be swapped out, and then yeah, it can trigger swapping out. And also, yeah, to swap out, yeah, we have to detach those pages from EPT tables. So we need to notification to KVM module. And this is a replacement for the existing MMU notifier. So yeah, essentially, yeah, what operation needs to be done. And yeah, I think, yeah, basically, we need a conversion, we need an allocation or deallocation of the backing memory. It would be done on VM initialization or dynamically when EPT violation happens. Yeah, we'd like to allocate the memory on dynamically. And also when EPT violation is happened, yeah, we need to convert from guest address to host physical address. And also, yeah, we need a notification for swapping out, and access dirty bit logging is needed. And actually, access dirty bit logging is done through EPT page table. So this interface will be a KVM interface. And the current dirty page logging interface typically used for live migration. So for live migration, yeah, the page needs to be broken into 4K page, because yeah, if we use simply large pages, yeah, probably yeah, dirty page won't converge to small working set. But for swap out, or overcommit, yeah, we like to keep large pages. So question is, yeah, how to implement it. And currently, yeah, emerging technology modifies QEMU and KVM each on their own. And they are making changes directly to KVM module or QEMU. And that is what's happening, but it doesn't scale. And so another choice is to introduce a new class of device driver, and then yeah, rewrite the existing device driver to adapt it. But I think yeah, this is a bit difficult. For example, persistent memory, yeah, it has a PMEM device driver. So probably it would be difficult to change PMEM device driver only for KVM use case. So yeah, third option is to define a wrapper interface and to write an adapter for each device drivers. And probably I think yeah, this option would be feasible at least in a middle term. So then next question is, what a concrete interface will be. And basically, the conversion from guest physical address to host physical address is considered a conversion from logical file offset to a sector. And in this case, we reinterpret sector as a host physical address. And this actually, this is what DAX does. And also, file system provides an interface for various options to allocate block. It's a F-allocate interface, and to deallocate block, it's a punch hole, and to prevent future end mapping, it's a shield interface. And when new VM is created and new memory is assigned to VM, it's a sort of, it can be considered a sort of new file creation, so it can be mapped to FA notify. So I chose to reuse file system interface. But if we'd like to make KVM a sort of type 1 hypervisor, probably we'd like to have our own self-contained interface. But I think it's a sort of very long-term direction. So at this point, I chose to reuse file system interface. And actually, conversion from logical file offset to sector is very file system dependent. So we need a file system. And it can be a very small suit file system just to accommodate to use existing Linux file system interface. And under that, we can write a sort of layered file system. It may complicate locking protocol, but I think Linux has already layered file system. It can be done. Not so it won't be not so difficult. And then interface will be looks like this. For initialization or DMA, probably QEM will use read or write, and instead of mmap. Or only at initialization we can use mmap and we can require QEM to unmap it. And then EPT violation happens. Block mapping block conversion logic can be triggered, and then it will be propagated to backing device driver, so that it can allocate actual memory. And QEM, and for swapping out or overcommit, we can use scanner or swapper can use a KVM interface to identify which page needs to be swapped out. And for swapping out, actually, file system interface, F-allocate or punch hole can be used. And then deallocation notification is sent to KVM module. And then EPT table will be updated and its cache will be flushed. For memory isolation, for security reasons, memory isolation is highly desirable. And basically, it removes user space mapping. It removes pages from kernel direct mapping, and probably we'd like to remove or eliminate struct page. But it depends on backing device drivers. If device driver wants struct page, we can. But at least KVM module or related module doesn't use struct page. And also for I/O or communication between guest VM and KVM module, we need a shared page. So that we need an interface for VM to tell which page will be shared. And probably for vhost user process has to map it. So because it's for performance. So in that case, we need to allow mapping, user space and mapping. So if there is a file system interface to shield, F control shield, but it's only simply prevent a mapping. It's all or nothing. So probably, I think, some interface needs to be introduced, or shield interface needs to be enhanced somehow. Okay, the current status. Right now, I have a sort of pseudo file system is written, and adapter for reserved memory is written. And then, right now I'm trying to remove a page fault interface from KVM module. But right now, it panics now, so I couldn't fix it for KVM forum, unfortunately. So it's a work in progress. So future work. So I'd like to start discussion, and also I'd like to finish the POC and to post patches to the mailing list. And then also benchmark is needed to, and also, the implementation is to enable future memory technologies. So I need to exercise other technology in addition to reserved memory. For example, encrypted memory or memory compression. And also, I'd like to ensure that live migration will work, and also VAT-IO, especially vHost user. And also, preparation for memory isolation. Okay, so I think, it's time to revise and refactor or enhance KVM guest memory management, and to provide or pave a way for new memory technology. And as a next step, I'd like to start discussion and to align with the current existing or current activities. Okay, thank you. So then I can take questions.
Hi. Can you elaborate about what is exactly the modification you did to the KVM model to the KVM model? Yeah, here.
Right now, KVM has a conversion from a guest physical memory to host physical memory. I don't remember exact function name, but it triggers a page fault.
But today, when KVM gets an EPT violation, then it calls the page fault function of the TDP page fault, and then it just looks at the page tables of QEMU, and it understands what is the PFN. And then if it sees that the PFN is not backed by a struct page, like in this example, then it just tries to create an EPT entry for that PFN, and that already works. So this is why I'm
right. So my modification is to skip those page table work and just to trigger call the device driver to convert file and file offset to give a host physical address.
And what is the purpose of that?
It's tied to page fault, tied to virtual address. So we don't want map those regions to QEM.
So you try to prevent QEMU user mode process from being able to access the guest memory in general?
Yes.
So this relates to the other hardening project in general, the VBH project, right?
Yeah.
Okay, now I see. Thanks.
So is that basically saying that because QEMU can't access this memory at all, you don't have to worry about having strict pages because you're not going to be doing any get user pages on that memory because QEMU can't access it?
Sorry, could you say that?
You're saying you're going to remove struct pages from this. The problem with that is like if you want to do a get user pages on that range, like for example, if QEMU does an IO to it, but you're saying it's not even accessible by QEMU. Is that right? Or how are you going to deal with get user pages in general if there's no struct pages?
Yeah, at least, yeah, even without struct page, yeah, it is possible to mmap with PFN mapping. But for I/O, yeah, probably I/O subsystem requires struct page. Yeah.
I think, does KSM work?
What?
KSM, deduplication?
Oh, yeah, probably no. For especially encrypted memory, yeah, we don't want KSM.
So just another wondering that I have. So if I understand correctly, at boot time, all the physical memory of the host is still available to the entire host until you take some memory and reserve it for specific dynamically at runtime for the guest, right? In this reserved memory.
Probably, yeah.
So what I'm considered wondering about is that one of the issues I see with this is that you still have. This is useful only for a use case that you use the host as a VM server that only runs VMs, not as a desktop environment. So in this case, you want most of the host memory to be pre-allocated for guest usage. So if you don't do that at boot time, then you will have fragmentation issues on the physical memory layout, and you won't be able to allocate 1 GB pages for all the guest memory, for example. So you would like to, at boot time, to preserve the memory to this pseudo file system and not at runtime.
File needs to be created, but memory doesn't have to be allocated yet until EPT violation happens.
Yeah, I understand, but I think this is an issue because you do want to make sure that once an EPT violation will happen, you will be able to find a 1 GB page without fragmentation issues. So you want your pseudo file system to be able to allocate this entire memory range at boot time and not at runtime.
Range is, what do you mean by range? Yeah, it's a file system range, file range, but memory does not necessarily to be assigned.
We can talk about that offline.
Yeah.
Okay.
Are you just linking this thing with pseudo file system you are mentioning so that whatever will be the page faults and everything will be taken by this pseudo file system part?
Yeah, that's a plan. Yeah, and actually it simply invokes that device driver, backing device driver, and then device driver will handle it. So the driver just a sort of a wrapper, at least to unify the interface for KVM. At least I think it doesn't scale to modify both QEM and KVM for each technology.
And what about page cache?
Page cache?
Host page cache or?
What do you mean? Yeah, right now, yeah, anonymous page is already, or regular file page is already handled by the existing code. So this enhancement will be added as an optional. I don't think the conversion will happen at once, so we will have a sort of conversion period. Or we can, at least, we can have options to do this. Any other questions or comments?
I want to know if the device model in user space wanted to access the memory, do you need to map the memory to user space?
Not necessarily. At least we can utilize read-write interface, but probably it encodes memory copy, so performance would be decreased. Or guest VM allows to share the page with the host or user space, we can map it. That's the plan.
Okay, you are also talking about memory isolation, right? So if the device model is on the user space, how do you make sure the memory cannot be accessed by the hardware on user space?
Yeah, for user space, for now, I'm considering about shield interface, F control shield, and actually it prevents future mapping, and also it ensures it's not mapped by any user process.
You mean after you use it, you will unmap it, right?
Sorry?
What do you mean is that after the user space used the memory, the user space will unmap it, right?
Map? No, so we can talk later.
Okay, thank you.
So thank you for your talk.
Okay, thank you.